Today's lesson we're solving systems still, but this time 3 variables. So it's the same process, but as you can see, more stuff, more details. I hope that as I go through my work I can show you my way of thinking as well as my system. Like I have a system, I imagine many teachers do, and this probably is not going to be new to you. We have 3 equations and 3 variables, and I'm going to call those equations A, B, and C to start with. The deal is when you're working with 3 equations, you have to pick a pair of equations and eliminate one variable. Then pick a different pair and eliminate the same variable so that you can get to a spot where you're at 2 equations, 2 variables, and then go from there. So you can read my wordage here. I'm going to try and get rid of the y's by multiplying the first equation, the A equation, by 3. That would allow me to get rid of y. So this is how I'm going to try and be very consistent and show you what I'm doing. I'm going to multiply A by 3, and then I'm going to add it to B. So 3 times the A equation, 12x plus 3y plus 6z, equals negative 24, and that's everything multiplied by 3. The B equation was 2x minus 3y minus 4z equals 4. Now I'm combining 14x, the y's have been eliminated, 2z, and negative 20. Next, I need to get this equation involved somehow, and I have to eliminate y. So I'm going to choose to do negative 2 times the top equation. So this time I'm doing negative 2a, and I'm going to add that to c. Negative 2a is negative 8x minus 2y minus 4z equals 16. The c equation, negative 7x plus 2y plus 3z equals 2. And now we're going to add them. That's going to get us negative 15x's. Y's are gone, which is what we wanted, minus 1z equals 18. At this stage now I have these 2 equations that I'm working with, and I'll go ahead and label them D and E as well, just to keep consistent. But I can see that if I multiply E by 2, I'll be able to combine. So I'm going to do D plus 2E, and the D equation is 14x plus 2z equals negative 20. Twice the E equation will get us negative 30x minus 2z equaling 36. And now when we combine, the z's will go away. Negative 16x equals 16. So that means x is negative 1 in this system, and that deserves, folks, a big smiley face, because now you're ready to start back substituting. That is, I'm going to take this value for x and I'm going to put it into either D or E. It doesn't matter which. Whichever one I choose, I'll be able to work and find a value for the other variable there, which is z. I'm going to go with E, so I'm going to put it into E. So negative 15 times x, and x is negative 1, minus z equals 18. That's 15 minus z equals 18. And negative z would be 3. That means if negative z is 3, then z is negative 3. And now we're ready to back substitute again. We can put our values for x and z into one of the original equations, and I'm going to put them in A. So I'm going to have 4 of my x's, which were negative 1, plus a y, plus 2 z's, and z was negative 3. That's got to equal negative 8. Negative 4 plus y minus 6 equals negative 8. That's negative 10 altogether, plus y equals negative 8, and adding 10 to both sides, y equals 2. So we have our solution, one solution to this system, and it's -1 for x, its y is 2, and its z is -3. When you're listing the solutions, they should go in alphabetical order. Or if you left it this way but just indicated where your solutions were, that would be okay with me as well. Right? As long as I can see what they are, that's the important thing. All right, lots of algebra, folks, and lots of places to make arithmetic mistakes. So you have to be on your toes. I have to be on my toes. I'd like to have you try that one more time. Well, I see that -x right there. I think I'm going to utilize that, or maybe I could go with the z's. Either way, we should come out to the same answer. Maybe I'll go for the z's. So I'm going to take 4 times the b equation and add it to the a. So I'm going to have a 4b. A is 6x minus 3y plus 8z equals 4. 4 times the b equation, so minus 4x plus 36y minus 8z equals 8. 4 times everything there. Adding 2x plus 33y, oh, that's kind of an odd number, 12. And I need to get rid of the z's now, and I got to involve equation c. So I'm going to go a plus 2c. A plus 2c. 6x minus 3y plus 8z equals 4. Twice the c, 8x plus 12y minus 8z plus or equals 6. All right, let's go ahead and add there. 14 x's, 9 y's, no z's, and 10. So I now have a little d equation and an e equation that need to be joined together so that we can get rid of a variable. And if we do -7 times d and add that to e, I believe we'll be on the right track. That'd be minus 14x. 33 times -7. 7 times 3 is 1, and 2 is 230. So 231y, and we're doing -7. That's -84. When we join that to this one, 14x plus 9y equals 10. 9 from that is 222y, has to be negative, and minus 74, and both negative. And I have insider information. 74 into 222, that reduces to 1/3. So we have a value for y which deserves, well, that's not exactly a smiley, but I'm not exactly happy at this moment because I got a fraction. I know it's right, but I don't like the fractions. I'm going to put that, I'm going to substitute back, and I'm going to put that into d. So 2x's plus 33 times 1/3 equals 12. 2x plus 11 equals 12. Subtract 11. 2x is 1 and x is 1/2, and well, I'm getting happier. We've got 2 of our answers. All that's left is to substitute both of these back into one of the equations. I'm going to come over here and put that into I guess equation A. It does not matter to me. 6 of the x's, which are 1/2, minus 3 y's, which are 1/3, plus 8 z's equal 4. 6 times 1/2 is 3. 3 times 1/3 is 1, so minus 1 plus 8z equals 4. This is 2 plus 8z equals 4. Subtracting 2, 8z equals 2, and dividing by 8, z is 2/8 or 1/4. Oh my goodness, every single variable was a fraction, but I know it's right. I have an x of 1/2, a y of 1/3, and a z of 1/4. All right, one more that I'd like you to work through with me, and this one may be something that you've not seen before, but it is accomplished easily with this technique. We're supposed to look at these 3 points and find the equation of a quadratic equation that passes through them. I just want to remind you, quadratic equations have this format: ax squared plus bx plus c equals y, and it just so happens we've got 3 really nice pairs of xy right there. So let's put those in and see if we can't generate our a, b, and c equations. So the first one, a times the square of x, and x is 1, plus b times x, which is 1, plus c equals the y value 4. Now I know that I can do a math there. 1 squared is 1, and so I'm going to get a, b, plus c equals 4. So there's my a equation. Let's use the next point with its x and y to generate another equation. A times, this time x is 2, so 2 squared plus b times 2 plus c is equal to 1 this time. Here comes my b equation. 4a plus 2b plus c equals 1. And the last xy pair that we have that we can use, x is 3 this time, so a times 3 squared plus b times 3 plus c has to equal 4. And here comes the last of our set of 3 equations, 9a plus 3b plus c equals 4. Now you can certainly choose any variable to eliminate. I can see the advantage of working to get rid of the c's, so I'm going to try that route, and I'm going to do a with the negative of b. So my a is a plus b plus c equals 4. The opposite of b, minus 4a minus 2b minus c equals negative 1. Negative 3a, negative b equals 3. Now I need to get rid of c, and I got to get this equation into it, so I'm going to do the same kind of deal. I'm going to do b with the opposite of c. So b was 4a plus 2b plus c equals 1. Negative 9a minus 3b minus c equals negative 4. And combining there, negative 5a minus b equals negative 3. Here's my d equation. Here's my e equation. And I need to get rid of a variable. Looks like b would be the easiest to get rid of. So let's do d with the opposite of e. D was negative 3a minus b equals 3. The opposite of the e equation, 5a plus b equals 3. 2 a's will equal 6, and a equals 3. That sounds right. A is 3. I'm going to put that back into, and it doesn't matter which of these I choose. I'm going to go with the d equation, which says, so I'm putting it into d. Negative 3 times a, and a is 3, minus b equals 3. That's negative 9 minus b equals 3. Adding 9 to both sides would get me negative b equals 12, and b must be negative 12. All right, 2 down, 1 to go. I'm going to now put those 2 back into my a equations, the easiest one to use because that's the one that says a plus b plus c has to equal 4. That's negative 9 plus c equals 4, and c would equal 13, and there you have it. The coefficients for a quadratic that contain those 3 points are 3, negative 12, and 13. That quadratic would give us 3x squared minus 12x plus 13 equals y. or 0 if we were going to solve it. Kind of an interesting application for systems of equations, and one that I had not seen before. So lots of algebra. You just really have to be careful with the SIGNs of things. It's easy to make sign errors here. It helps to try and stay organized. So I don't know if you like the little letter system, but that certainly helps me. So I'm going to ask you to try that. You try at your soonest, and I'll see you in school.